This conference will now be recorded.
Good morning, all of you. I welcome you all for category development program, so which we are running on the 4th day. Okay. So today we are going to have Arun as a presenter. So I hope even Tejashwini also will be in online. So he will brief the yesterday's session and he will start the content, which we are going to have it today. Guys, please inform your friends. So please log in immediately. Okay, we'll have the session as soon. Start the session as soon, right? You can please text your friends, so by that they will come at least by 11 o'clock. Sir, meeting. Guys, can you see my screen? No. 1 second. Yeah, now it is fine. Yeah, so trainer will be in online in couple of minutes. Okay, so you can be ready with your questionnaire. If you have any questions regarding with the yesterday's session, okay, you can put questions straight when the session starts. Okay, so by that we can continue for the today's class. Okay, so just a couple of minutes, so trainer will be on online. Please, you can have questions, right? So you can ask Arun. Okay, any doubts related to software, any doubts related to analysis and design part, even doubts on code? Okay, you can put questions to Arun. Okay. So there are only 17 participants. I request all, please inform your friends to log in immediately. So because we are going to start the session in a couple of minutes, please guys, please inform your friends to log in immediately. If you have any group or any chat, you can chat them, and please ask them to log in immediately because there are only 17 participants today. Yes, so please be patient. I think there is some technical issue with the trainer. Okay, in his system, go to meeting is not opening right, so he is reinstalling again. Okay, so please wait for 5 minutes. We'll start the session. Okay, and please you can inform your friends in between to log in immediately. Okay, so by that they can also be in time once we start the session. Okay. Hello. Yeah, please guys, please bear with us. There is a small technical problem in trainer's laptop. So GoToMeeting is not opening. So he is uninstalling and reinstalling it again. Okay, please, sorry for the inconvenience. I hope you understand the technical issues arises through these online sessions, right? I hope you all understand this. Okay, please bear with us. Maximum to 10 minutes. Okay, if still the problem was not resolved, what we do is we will send you a new link with what is that Google Meet. Okay, so instead of GoToMeeting, we will have a Google Meet link. Through that, at least we can start the session. Okay, no worries. Somehow we will try to engage today's session. Okay, so but maximum we will try to rectify with the GoToMeeting itself. If not possible, then we'll go with the Google Meet. Okay, I will try to share you the link as well. Okay, so please bear with us for 5 to 10 minutes, guys. Okay, and in between, if there any possibility, please try to install Google Meet also. Okay, Google Meet also, please try to install in your system. I will share the link in chat box. Okay, so with that, at least you can have that session. If it is not coming up with the GoToMeeting, okay, I will inform you in 5 to 10 minutes. So please bear with us. Thank you. Yeah, even Tejashwini is also participating. I mean, she is also attending this session. Okay, if not possible with Arun, so she will engage the class. So anyway, both will come today. So somehow we will try to do it in GoToMeeting because all participants are already there in GoToMeeting. So we'll continue in the same. So it's better to install Google Meet software also, right? So please excuse us, guys. Sorry for the inconvenience.
Good morning, all. I think I'm audible.
Yeah, audible Tejashwi. I think Tejashwi is online now. So
Yes.
until Arun's problems get rectified, Tejashwi will continue the session. I welcome Tejashwi for fourth day of faculty development program on SAP-2000. Right, Tejashwi, I will make you organize now. So by that you can start the session. Okay.
Thank you, sir.
Yeah, Tejashwi, now you can start presenting. You are the organizer now.
Good morning, one and all. For the fourth session of this FTP, uh, from from yesterday's session, we have been discussed about what is pushover analysis and why pushover analysis has been being used. And yesterday we have discussed about pushover and pushover analysis for a newly constructed building. Today's session is pushover analysis for an existing building. So let me share my screen. till uh, till today's session starts, let's recap our yesterday's session. Yesterday we have discussed about first we have discussed about how to apply lateral loads, how to apply loading. First of all, how modeling, loading, assigning of loading, and how to do concrete design. And then we have came into nonlinear static analysis. In that we have seen pushover analysis. Pushover analysis is a nonlinear static analysis, and pushover analysis is mainly used for two cases. That is for existing buildings and for newly constructed buildings, and it is used for performance-based design of a building. So we have seen the procedure for pushover analysis yesterday. Just we recap that procedure. For doing pushover analysis, first we have to analyze the building. First we have to do modeling, and we have to do and first we have to do modeling, and we have to assign loads. First we have to design the building, and then we have to first we have to analyze, and we have to design that building. After that uh, we have to push the building with a gravity load of dead load plus 0.25 live load. This is a model that we have done yesterday. We first we have to go to define. After analyzing the building, then we have to go to load cases. In that, first we have to do a gravity. We have to define a gravity load, that is non-linear static load, in which we have to do that dead load plus 0.25 live load. By this load, we are pushing the building with a gravity load. So first we have to define a gravity load. In this, we have to put none and click on OK. And then next we have to define push X and push Y. If we are push X and push Y, if we are pushing applying the load in X direction, we have to we have to define push X, and in Y direction we have to define push Y. So click on first modify and show. We have to define push X. For push X, we should continue from gravity and continue from the state at the end of non-linear place, that is gravity. And we have to see that it should be static, non-linear, and here geometric non-linearity is not there, so none. And we have to see here the scale factor should be -1, as our curve will go to if it is a +1, the curve will go to left side, that is it will be in negative. If we give the scale factor as -1, then the curve will be in positive direction. Next, the load application for push X should be a displacement control, and it should monitor the displacement. And this monitored displacement is calculated as normally 4%. 4% of the height of the building is taken as a 4% of the height of the building. And the procedure for pushover analysis is from FEMA 356. FEMA 356, it has been clearly explained in FEMA. So use a monitored displacement of 4% of building height. As our building is a 3-story building, then it is a 9 meters, 9 into 0.04, that is 0.36. This is a maximum, this is a used to monitor displacement. And next, monitor displacement degree of freedom should be u1, as we are pushing from one direction, so degree of freedom should be u1. And at joint means we should take a node point where we are applying this push X. So we have taken a node at 3. So click on OK. After defining all this in pushx, click on OK. By this pushx, this structure or a frame will be pushed for every for every step with a gravity load of this. For every step, it will push up to the building ultimate load, the ultimate capacity of the building, ultimate load and ultimate displacement will be obtained from this. Then click on OK. Just after all this, just go to analyze and click on run analysis. Just run. This is a procedure for a normal pushover analysis, and procedure for uh, existing building. For existing building, we should know the reinforcement, longitudinal reinforcement of the beams, columns of the building, and then the grade of the concrete of the building. We don't know the concrete grade. As the building will, as the age increases, the uh, concrete grade will be. For example, we have mix the concrete mix is N30. As the age increases, the strength of the concrete will be also increased, that is it may be N34 now. The span of the building, the lifespan of the building may be 10 years. So by rebound hammer test we can calculate the strength of the concrete, or strength of the concrete. After calculating the strength of concrete, we can impart that N34 or N30 grade of concrete in materials here. And after that, we should know the longitudinal reinforcement of columns and beams before we start the pushover analysis of the existing building. After that, we should here we should use a section designer for drawing for taking that beams and columns into consideration. So we should use a section designer for existing building to take beams and columns. So after
Hello, Tejaswini?
Yes, sir.
Any
Yes, sir.
problem?
Sorry. No, sir.
No.
No, sir.
Okay.
Sorry for the interruption.
Yeah.
After section designing, in that we should know the reinforcement. In that we should know the reinforcement. What reinforcement area of the steel? How many bars we should? How many bars have been provided in beams and columns? We should know all this data before doing pushover analysis for an existing building. So today's session we will see about how to do how to do section designing, and next how to apply hinges. Here we have given auto hinges. Auto hinges we have given for these beams and columns, but for an existing building we should not give auto hinges. We should take user defined hinges. We should take user defined hinges, and that hinges will come hinges we should provide from moment curvature graph. We should take from moment curvature graph, where after analyzing, just I am explaining the procedure that for a pushover analysis for an existing building. After that we will do practically. After taking moment curvature graph, from that we will get yield point, yield point, maximum yield point, next maximum one point up to which the building is in up to which the concrete reinforced concrete is an elastic limit. That point we will take moment and curvature we will take, and next after that the ultimate point, at that point we will take moment and curvature, and next at last we will take yes, this has been analyzed. Now we will see after that we will after taking that points, we will apply these values in user defined hinges. We will define user defined hinges there. Then after defining the user defined hinges, we will just apply these hinges on beams and columns. So this is a main part for existing buildings. For existing buildings, this is a procedure to do pushover analysis. Next, this analysis. Till Arun join, I will just explain the section designer part. Just go to define, click on section properties, click on frame sections. Yes, click on frame section. Yes, I think Arun has joined. Yes,
Yeah,
go to define.
Yeah. 1 second, Tejashwi. I will just welcome Arun.
Okay,
Arun, is it audible now?
Am I audible, sir?
Yeah, you are audible to us.
Okay.
You are audible. Yeah. I welcome Arun. Yeah. So I think I will make Arun as an organizer. So by that he will handle the session. Yeah, Arun. Now you are an organizer. You can talk to the participants now. Okay.
Okay.
Tejashwi, you can also be in online. Okay, no issue.
Yes.
So
Yes,
yeah,
sir,
we
yes,
all
sir,
will
yes.
be the organizers. Yeah. Arun, go ahead. Yeah.
Okay, sir. So are you able to? Are everyone able to see my screen?
Yeah.
Yes.
We can
Yes.
see your screen.
Yes, sir.
Good morning, everyone. I apology for the delay. Actually, I was facing from some issues with the GoTo app, so that's why I was delayed to attend the meeting. So I hope Tejaswini has taken the meeting until now. Hope you guys are familiar. You guys got introduced to how to model a structure and how to apply loading, right? So I want you guys to respond in the chat box. So if there is anything, any like if you want me to slow down or anything you don't understand, or if you want me to repeat anything, just put them in the chat box and I will explain them once again. Okay. In today's session of SAP 2000, we are going to learn about pushover analysis and then time history analysis. In this pushover analysis, there are two types of pushovers which we can perform in our SAP 2000. The first pushover is using auto hinges. You can note them down. The first pushover type is using auto hinges, and the next one in the next type is using user-defined hinges. Okay. The first pushover type is auto hinges, and the second pushover type is user-defined hinges. And the next one, after completing the pushover analysis, we will be going to time history analysis. Okay, the first one which we are going to discuss in today's topic will be pushover analysis, and after that we'll be going to the time history analysis. In this time history analysis, we'll be having two types of time history analysis. One is by using unscaled ground motions or unscaled accelegrams, and the second one will be using scaled accelegrams. Okay, so without delaying, I am going to start the pushover analysis. So the first thing which we are going to learn in this pushover analysis is using auto hinges, is developing a model and using auto hinges. Using auto hinges, we will be doing this pushover analysis. So what exactly is this pushover analysis? So whenever I'm telling pushover, so what exactly is the meaning or the definition of this pushover analysis? A pushover analysis can be also defined as a static nonlinear analysis.
In that student's book.
All student books.
No.
Hello.
No, Arun, you can continue, Arun. You can continue. And you can hold your mic bit closer, so by that it will be audible. I mean, your audio will be clear. Okay.
Yes, right. Yes, sir. So whenever I'm talking about pushover analysis, it is also defined as static nonlinear analysis. So guys, when I'm talking about static nonlinear analysis, what do you mean by a static analysis? There are two types of loadings. The first one is static loading and the second one is dynamic loadings. So what do you mean by a static loading? You can answer in the chat box, guys. You can put your answers in the chat box. So what do you mean by a static analysis? Okay, I don't see any answers in the chat box. Guys, you can respond using the chat box. Okay, fine. So what exactly is static analysis is? Load is constant along with the time. Analysis by gradually applied loads. Actually, the static analysis is nothing but the load is constant with the time, like in which all the components are in elastic commit. Okay, that thing is like coming under the linear and non-linear. But what does a static analysis means? The loads which we apply on the building are constant with the time. They won't be changing along with the time. Okay, this type of loadings are called as static loads. Whenever we are talking about the static loads, we have to remember that all the gravity loads, like the dead load, the live load, this are considered as our static loads. And sometimes the earthquake loads and the wind loads, which change along with the time, like they won't be the same along with the time, those loads are called as dynamic loads. Okay, the main difference between a static loading and the dynamic loading is that static loadings, all the loadings are constant with the time, and when you are coming to this dynamic loadings, this load will vary accordingly with the time. Like sometime it will be more intensity, sometime it will be lesser intensity, sometime it will be much more intensity. This type of loadings are called dynamic loadings. Okay, whenever I say this pushover analysis, it is static nonlinear analysis. Okay, the first part we have understood what is static, and the second part, it is a non-linear analysis, right? So what do you mean by a non-linear analysis? What do you mean by a linear analysis, and what do you mean by a non-linear analysis? If anyone can explain, just put them in the chat box. What is a linear analysis and what is a non-linear analysis? You can respond in the chat box, guys. What is a linear analysis and what is a non-linear analysis? Okay, fine. Let me explain about this. Whenever we are talking about a linear analysis, the materials which we use for the modeling or anything modeling which we load upon linear analysis for elastic bodies, non-linear means for non-elastic. So the thing is that linear analysis, it follows, yes, exactly, in linear analysis it follows the Hooke's law. Like within the elastic limit, stress is directly proportional to the strain. What exactly in this linear analysis happens is that the materials which we use in the SAP-2000, like the materials which we create and the geometry which we create, like the length of the beam or length of the column, all the deformations or the stresses or the strains will be completely under the Hooke's law or the limit or under the elasticity limit. Whenever we do this linear analysis, linear type of analysis, all the deformations, the stresses and everything will be under the Hooke's law, under the elasticity limit. So whenever we apply a load, it will be only taking below the yield point. It won't be moving further than the yield point. So this type of analysis is called a linear analysis, considering the material, assuming the material to be within the elasticity limit or within the yield point, within the Hooke's law. This type of analysis is called as linear analysis. So whenever we go for the linear analysis, all the materials will be under this elasticity limit. Now, as we say, pushover analysis. Pushover analysis is a static non-linear analysis. So you have understood this. What is this linear analysis? Now the next part is non-linear. So I think you guys are able to understand what non-linear is, right? Just the opposite of the linear. Like after the elasticity limit, there will be a yield point. There will be a yield point, right? So whenever we do the analysis, assuming the material or the geometry or the model to be deforming more than the yield point, it is called as non-linear analysis. Okay, I think there is a drawing tool over here. I'll be using one thing, pen. This one will be your, whenever you see this mild steel curve, mild steel or stress strain curve, this will be your A point, this will be your B point, somewhere it will be your C point, and here it will be your D point, and here it will be your E point. So whenever we see this curve, see this type of plot, from A to B, it is in the elasticity limit, right guys? From A to B, it is in the elasticity limit. And if we consider all the materials to be in this elasticity limit or under this B point within the yield point, this type of analysis is called as a linear analysis. Okay, This type of analysis is called as a linear analysis. And after that, after completing the yield point from B to C and C to, this is the maximum point, this is the ultimate point, and from here it will be dropping to the E point. The whole thing after the B point will be considered as nonlinear analysis. Okay. So this is the difference between a linear analysis and nonlinear analysis. Now let us start with the pushover analysis. In order to perform a pushover analysis, we need to have a small model. So I'm just creating a model, clicking on the file, click on new model. Hello. Yeah, Suresh, is there anything you want to ask me? Okay, fine. So in this, I'm just selecting the 3D frame. 3D frame, it is an open frame building. I'm just leaving the dimensions to be default. If you want to change, you can change from here, or else you can use the custom grid spacing. And I am using the beams and columns to be default. After opening the model, I'll be creating the beams and columns. And click OK. And your model will be formed. Now what you have to do is, I think in the previous class you have understood how to create materials and how to create sections and how to apply them. Now I'm just skipping that section, and I'm just going forward to the pushover analysis. I'm deleting all these sections. I'm selecting all these sections, and I'm deleting these sections. Okay. Now I'm creating new materials for our pushover analysis for our model. In the define, in order to create a new material, in the define, click on materials, click on add new material. In this, select the region. This steel is the structural steel, and this rebar is the reinforcement. The steel which we use in I section, C sections, or any industrial columns or beams, we will be using this type of steel, and this rebar is used for reinforcements, like the main longitudinal reinforcement and the tie bars. We will be using this rebar. Now for our model, I am selecting 415 HYSD grade 415 bars for the ties, and again add new material. I am selecting HYSD grade 500 FE 500. I have selected two more. I have created two grades of reinforcements or rebars. After that, I'm creating a new material. This one will be our concrete. I'm using M30 grade of concrete for our model. For the columns, I'll be using M30, and for the beams, I'll be using M25. Add new material, and for the beams, I'm creating a new material which is M25. Okay, so everyone are clear until now, right? You can respond in the chat box. You are clear until now, right? I have created a new materials. Just click on define. Click on define, add new material, and I have created 4 materials. The first material is for our tie bars, which is 415. The second material is for our main longitudinal steel, which is HYSD 500 bars, and then M25 and M30. M25 I am using for the beams, M30 I am using for the columns. Okay, click OK. Now the next thing which I'm going to do is I'm going to define my sections. Now we have first created our materials. Now I'm going to define my sections. For that, I'm going to click on define, click on section properties. In the section properties, I'm going for frame sections. In this, I'm clicking on add new property. For the first method of pushover, we are going to use auto. You can create a normal section just by clicking on this option, like a concrete rectangular section. You can create a normal section, and you can give the length and width of the section. Click on rectangle, and then give it as column. I'm taking this as C1, and then I'm changing the dimensions 0.460 by 0.230. Whenever you are giving this dimension, you have to think in a way that how the construction residential buildings or the construction of the commercial buildings works out. Like the centering plates, the framework which is available in the market will be from 12 inches, 15 inches, and 18 inches and 21 inches. So whenever you increase the size of this depth or width, you have to keep in mind that you are increasing increment of 30 mm. You are increasing an increment of 30 mm. So this 230 is nothing but your 9 inches, and the framework which is available will be starting from 9, 12. It will be the multiples of 3. So whenever you are giving this depth and width, you have to remember these things. It will be the multiples of 3. Whenever you are increasing, you have to increase like 30 mm for every increment. 30 mm will represent like 3 inches. Okay. Then after that, you have to give the base material. As this is our column, I'm giving the base material as M20. Okay. And after that, I'm going to create the concrete reinforcement. I'm going to create the concrete reinforcement. In this, for the longitudinal bars, I'm selecting HYSD 500. Okay. And for the confinement bars, I'm selecting 415. Now it is a column design. We have to consider P, M2, M3. P is nothing but your axial load. M2 is the major moment, and the M3 is the minor moment. Sorry, M2 is the minor moment and M3 is the major moment. And after that, you can leave this to default, as we are going, if we are using this design tab, this values, whenever you give this values, this will be changed when you are going to give the design. So you can leave this to your default values and then click OK. Okay. And here at the ending, you have to click on reinforcement to be designed, as we are going to design, and click OK. And again, click OK. And the new section will be formed over here. Okay. Now I'm creating a copy of that property. Add copy of that property. And this, I'm just changing the name to B2. B1, sorry, B1. The C1 is your column and B1 will be your beam. In this, I'm just changing this to, I'm changing the depth to some 360 and the width to 230. Why I'm keeping this 230 is the beam will be aligned with the wall, aligned with the 9-inch wall. So I'm just putting this to 230. Now I'm just changing this material from M20 to M25. Okay. And then the concrete reinforcement, I'm going to change this to beam, and just I'm clicking this OK, and click OK again, and again click OK. So this materials will be saved now. This materials will be saved. Whenever you are creating a new material, you have to remember one thing, that after creating the materials, like now I am add a new property, sorry, add a copy of property, some T1, I have added T1. I've just click OK over here. And after creating, if you click on the cancel button, the latest created material won't be saved in this frame properties. I repeat this once again. After creating a new material, if you click on this cancel, this won't be saved. You have to click on this OK. Okay, now I'm just clicking on the cancel, and let's see if this T1 is saved or not. I'm just clicking on this cancel and click on define section properties, frame sections. So the T1 has not been created. Okay. This is how to create your beams and columns. And whenever you do this nonlinear type of analysis, it is better to avoid a slab section. It is better to avoid a slab section or a deck sections. Why? Because whenever there is more mass, whenever there is more mass in the structure, like your slabs or your shear walls, it is difficult for the analysis. It will be much complex for solving the equations in the analysis for the software. So it will be lagging a bit if you use the slabs. Instead, what you have to do is you have to convert the slab load into an equivalent beam load. Like you have to convert the area load to and distribute it towards the beams. I'll be also showing you how to distribute that, and I'll be sharing you the Excel file, like how to distribute it to the beams and to the adjacent beams. For now, I'm just continuing with my pushover analysis. Now I have created the beams and column sections. Now what I have to do is I have to model the structure using those sections which I have created. So for that, I'm going to click on draw frame cable, quick draw frame and cable. In this, and I'm just activating this view. I'm putting this on the XY plane. And I am just dragging it over. I have to select the section. Sorry, I have to select the section. I'm drawing the beams for now. So I'm clicking on this B1 and I'm dragging it over here. Okay. And again, I'm going to, this one is the top section. If you put this in the 3D view, you can observe this one is the top section. I'm going to the, I'm selecting the active window. I'm just going down. And again, I'm dragging over the sections and you have created it over here. Okay, now next what you have to do is you have to go to the elevation view using the XZ or YZ. Click on the XZ and then select the draw frame cable or quick draw frame cable. Change the section. I'm selecting the C1 section. Okay. You can also drag this, but the thing what happens when you drag this from here to here is the beams will also get changed. The beams will also get changed to the C1 section. So it's better you just draw them manually. You can change the color of beams and columns. Yes, you can change the color of beams and columns. I'll be explaining them in a bit. Let me draw this. Okay. In this, you will be having an option called set display options. I'm answering to Ahmad Ali. In this, you will be having an option called set display options. In this, you will be displayed with general options like in this general options, you will be having the different options like how to display the colors. If you click on sections and click apply, the colors of the beams and sections will be changed. If you click on the materials, depending on the materials, all the materials are of steel and this one is M30 and this one is M25. Sorry, this one is M30 and this one is M25. Beam is M25 and this one is M30. Column is M35. Depending on the materials, they will be changing their color. I'm just putting this two sections back again. Apply. Okay. Now, if you want to change the color of this section, what you have to do is you have to click on this define in the section properties, go to your frame sections, modify show properties, and then you'll be having a small option at the top right. In the top right, if you click over here, you can change the section color. Click OK. Click OK. Okay. Now the color of the beams and columns have been changed. Is it clear, Ali? Okay, so I'm just continuing with the pushover analysis. Now I'm going to the ground level. This one is 0 level. Now I'm just changing my cursor to set select mode. I'm selecting this, and I'm selecting all the joints at the bottom. I'm selecting all the joints at the bottom, and then I'm clicking on assign, click on joint, and then click on restraint. And this restraint will be having different types of restraint. The first one is a fixed restraint. So click this and click apply. Okay, right. Now we have completed our modeling without the slabs. I'll be explaining you how to convert a slab load towards the beam at the end of the session. Okay, now I'm just going to the 3D view again, and I'm going to assign the loads. Now I'm clicking on this load patterns, and I'm creating a new load for our live load. Live, and this live, and add new load pattern. Click OK. Okay, now in order to assign the loads to the beams, first you have to select the beams. You can select them individually, or else you'll be having the option in the select for selecting the properties of frame sections. Just remember the path, guys. In the select, properties, and then frame section. Click on the frame section, select the B1, and click on select. Okay, this is one of the method to select the beams, and we also have another method, that is in the select parallel lines, and then click straight line objects, and then select the select straight line objects, and select a beam, and all the beams parallel to that direction or that axis will be selected. And after that, click on select, and again select lines parallel to the object, and select this one. Select line parallels to the straight line object, and select the beam. Okay, now all our beams have been selected. Now click on assign. In this assign, click on the frame loads and distributed, and then I am just changing the dead load to live dead load. I am giving the dead load of our what do we say, the wall dead load. You have to calculate it from the ISC 875 part 1. For the dead loads, you have to calculate the length of the wall, you have to calculate the thickness of the wall, and the height of the wall. You will be getting the volume, and you have to multiply it with the densities. You will be getting the uniform load. Generally in the residential buildings, for a 9-inch wall, we'll be giving a uniform load of 12.5 kilonewtons or 12 kilonewtons. Sometimes it will be 13 kilonewtons per meter, depending on the materials which we are using as the brick. Like if we are using like burnt brick or aerated concrete brick, the densities will be changing. So depending on that, you have to calculate, and you have to give the uniform load. Now for now, I am giving the uniform load as 12 kilonewtons and clicking on apply. Okay, 12 kilonewtons load has been given in the dead load. Now again, I'm going to select, I'm clicking on get previous selection. All the beams which you have selected before will be selected again. Click on assign, click on frame loads. In this frame load, click on the distributed load. Now I'm going to the live load, and I'm just entering a live load of 2 kilonewtons, which is considered like our floor the slab live load. If we convert it into an equivalent beam load, I'm just considering it as 2 kilonewtons per meter, and I'm clicking OK. Now click OK, and now the 2 kilonewton live load has been also applied on the beams. Right, guys? Are you clear until this point? Like the modeling and the loading part, you guys are clear, right? Respond in the chat box, please. Only one response I have got. Okay. Yes. Okay. Okay. After this part, what you have to do is, in order to go further for our pushover analysis, you have to create a property called hinge. A property called hinge. A hinge is nothing but a part of a point in a beam where it starts to yield. Like whenever the capacity of the beam, the load carrying capacity of the beam is exceeded, at a point it will start to deform. At a point in the beam or the column, it will start to deform. In order to capture that deformations or capture those exceedance in the levels of stresses or strains, we need to create a hinge. Like whenever the material is changing from, as I have explained before, whenever a material is changing from its yield point, like from the B point to the C point, it is whenever it is starting to yield, this hinge will capture that changing, and it will activate the hinge. It will show us this part is going to fail, this part is yielding, and this part is going to fail. It will show. So in order to represent those type of scenarios, we'll be using hinges in the pushover analysis. Okay. In order to define those hinges, what you have to do is you have to click on define. In the section properties itself, you will be having the hinge properties. In the hinge properties, you have to click on add new property, and what type of hinge you are going to create is a concrete hinge. Click OK. Sorry, this one is for auto hinges. Sorry, this one is for user defined hinges. 1 minute, guys. This one is for the second part. I just brought it into the first part. 1 minute. Okay. You have to select the beams first. You have to select the beams first, and you have to click on assign frame, and then you have to click on hinges. I repeat this once again. For using the auto hinges, you have to click on the frame. In the assign, you have to click on the frame. In this, you have to click on hinges, and you have to give the relative distance of the hinge where you are placing it. Either you can, according to ETC 40 and FEMA 365, these are the two code books which are provided by the US government, like those standards, American standards, ETC 40 and FEMA 365, FEMA, FEMA 365. You can provide the relative distance at 0, 1, or else you can provide relative distance at 0.95 and 0.5 at the starting and ending. For now, I am creating the relative distance at both ends, 0 end and then the 1 end. So I'm creating a 0 end. The hinge properties is it is an auto hinge. It will automatically calculate the moment curvature of the beam, and it will create a hinge. I'm clicking on add hinge. In this, you will be asking, this one is nothing but ATC 40, ASCE 41. In this, you have to select the option called concrete beam. As we are applying the hinges to the beams, you have to select the property called concrete beam, and then this one is dead. Okay, click OK, and then in this you have to select one and click on add hinge, the same properties, and click OK. And again, in order to apply, click on this apply button and click OK. Okay, as you can see, the hinges are formed at the starting and at the end of your member. These are the relative distance. The starting relative distance is 0 and the ending relative distance is 1. Whenever you see there is a small distance, but this is not considered. This one is just at the start of the beam, and this one is at the end of the beam. Okay, after that you have to define a small load case before defining the hinges. For that, you have to go to the load cases. You have to create another load case, which is add new load case. This one should be your gravity load case. You have to create, this is a procedure for pushover analysis using auto hinges. You have to create a load case, gravity, and in this you have to change this to static nonlinear. In this you have to change this to static nonlinear, and in the load patterns, this is the load type. You have to click on load pattern. The dead load, we are giving the complete dead load, and we are giving the live load to it 25%. So it will be 0.25. Click on add. You have to create a new load case, which is gravity, and in this gravity the load type should be load pattern, and the dead load, you have to give it the scale factor as 1. You are using the complete dead load, and you are using the 25% of the live load. This one is for carrying out pushover analysis. This load case we are creating in order to carry out pushover analysis, and then click OK, and your new load case has been created. After that, click OK, and define. You have to select the get previous selections. Okay, select properties, frame sections, the B1 section, select. One. Okay, all this are selected. Now what you have to do is you have to modify the hinge. Like previously I have given it dead load. I'll show you how to modify the hinge. The frame, the hinges, you have to click on this. If you click on add, it will add a new hinge. If you click on this replace, it will modify the existing hinge. So I am clicking on this replace. If you see over here, total number of hinges on all selected frame objects is 68. You have to replace this 68 objects. So for that, click on add hinge. In this, select the concrete beam flexure item, and then in the dead load, select the gravity over here. In this you have to select gravity. Previously I have given it as dead. Why? Because I haven't created a gravity load case. So for now, after creating the gravity load case, you have to click this. You have to select this gravity, and then click OK. I have created at 1 distance, and I'm creating a new hinge at 0 distance. Gravity, and then click OK. Okay, at 1 and at 0. And now I'm replacing all the previous hinges with the new hinges. Apply. Okay, this part is completed. Assigning the hinges for the beams is completed. Now we have to assign those hinges for the columns. For that, what you have to do is, again, you have to go to the select. In order to clear this assignment display, what you have to do is, whenever your view is displaying something like this, or it is displaying the sections, or it is displaying the loads, in order to clear those all these things, and in order to get back to the view, to a clear view, you have to click on display. Sorry, you have to click on assign. You have to click on assign, and you have to click on clear display of assigns. Okay, so everything will be cleared over here, and then select lines parallel to, click straight line objects. I'm selecting all the columns. Okay, now if you see, I have selected all the columns, and I'm clicking on assign frame hinges. In this, a frame hinge at 0 distance, add hinge. This one will be our concrete column, and the load which we are considering, these are the different degree of freedom. The load which we are considering is for axial loads and the moments. We are considering the hinge for axial loads and the moments. So you have to select M2, M3, and then in this case combo, you have to select the gravity and click OK. And again, you have to create another hinge at 1 distance, add hinge, and then in the gravity, click OK. At 0 relative distance and at 1 relative distance, you have created 2 hinges. Apply. Okay, so if you see, a hinge is created at the bottom, and another hinge is created at the top at 0 distance at 1 distance. Okay. Now you have what you have to do is you have to define another load case, which is our gravity, which is our pushover load case. In order to define this pushover load case, you have to understand the model first. Assign. Generally, by default, this pushover load case will be acting at somewhere at the edges. Like in this direction, our it is giving the push to the structure, so it should be avoided. If you create a load over here, this whole building will be twisted. This whole building will be twisted, and the pushover won't be applied in the correct way. So what you have to do is you have to select the joint at the midpoint. You have to select the joint at the midpoint, and you have to get its label number. If you right click on the joint, you will be getting the label number, and the label is 38. Now we are going to apply the pushover in the x direction. The label is 38 and we are going to apply the push in the x direction. Okay. For creating the pushover, you have to click on define, click on this load cases. In this load cases, you have to click on add new load case. Pushover x direction. Pushover x direction, and you have to click on static nonlinear. You have to click on static nonlinear, and in this you have to click on acceleration in the direction of ux, and the scale factor you have to give it as -1. Acceleration ux and the scale factor you have to give at -1. Click add. Okay, after giving this, you have to set few parameters in the other parameters. In the load application, the load application is a displacement control, and as we have given, the joint is 32, right? And do anyone remember the joint? Please post it in the chat. The joint number, just before I have explained. The joint number is 38. Okay, 38. At the joint 38, in this degree of freedom, you will be having a few different types of degrees of freedoms. This one is u1 is nothing but your x direction, u2 is nothing but your y direction, z direction, r1 is rotation in the x axis, r2 is rotation in the y axis, r3 is rotation along the z axis. So now we are considering it in the x direction, so we are putting this u1. Click OK, and the results saved. In the result save, now we have changed the load application. Now we are going to the result saves. In this, click on the multiple states, change the number of saved steps to 100 and 1000 depending on the structure which you are working on. You can change the number of steps or number of saved steps. For smaller structures, and 100 and 1000 will be enough. If you go for complex and larger structure, you have to increase the number of saved states and the saved steps. Click OK, and in the nonlinear parameters, you have to change the event lumping tolerance relative. If it is 0.01, you can either provide a 0 over here, like you can change the position of the decimal places. This one, when you have to change is whenever you are not getting the convexity in the pushover curve, you need to come back to the solution control and you have to change all these values. For now, I'm just putting them to default. And if I don't get any pushover curve, if I don't get a converged pushover curve, I'll be coming back to this and I'll be changing. I'm clicking OK. And then in this, one more parameter which you have to change is continue from state at end of nonlinear case. You have to select this parameter, and this you have to select the gravity load. We have defined the gravity load before, so for you have to change this to continue from state at end of nonlinear case, and you have to click on gravity, and then that's it. So the first thing, you have to go for static nonlinear analysis, continue from the gravity load case, then you have to load type as acceleration ux and the scale factor as -1, and then the load application will be your displacement control. In this monitor shows monitor displacement, and this one will be your joint which you have selected, and then click OK. You can use any type of displacement over here, either it will be a monitor displacement or a conjugate displacement. What happens when you change this displacement, the magnitude of displacement is, whenever the pushover curve is forming, it will reach up to 0.24 meter or mm, and then the pushover analysis will stop at that point. If you want to increase the length of your pushover curve, you can change the value over here, like from 0.24 meters to, you can change it to 1 meter or anything else. Okay, you can use anything over here, like conjugate displacement or monitor displacement. If you want to monitor the displacement, you can change this value, like you can change this to 1 or 0.75 meters. Basically this value will be 0.4% of the total building height. This value will be 0.4%, 4% of your building height. And I'm just changing this to conjugate displacement, or else I'll be putting this to monitored for now, and click OK, and again click OK, and your pushover load case in the X direction has been created. Now again click OK. In this way, your pushover load case has been created. We have created the material, we have done the loadings, we have assigned the hinges, we have created the pushover load case. Are everyone clear until this point, or any part which you want to explain me once again? Do you want me to explain any of the part once again? If anyone doesn't want to explain me once again, I'll be going forward to the analysis part. Guys, please respond in the chat box. Okay, so I'm going for the analysis part now. In this, no sir, it's clear. Okay, I'm going forward for the analysis part. Click on analyze. In this, set load cases to run. So remember one thing, guys, whenever you're running a pushover or any nonlinear load cases, first you have to run the basic load cases first. First you have to run the basic load cases, and after completing the analysis you have to run again for the pushover load case. Okay, now I'm clicking on run now. Depending on the complexity of your model, depending on the different materials and different geometries which are in your model, the pushover analysis will take a little bit of time. You have to wait a little bit of time to get the pushover analysis. For this type of structures, it will be completing very soon. For larger structures, it will be taking a lot of time. And in this, if you click on display, as you see over here, there is no pushover curve over here. In order to activate it, once after completing your analysis, you have to go again to analyze, set load cases to run. Now what you have to do is, you have to click on do not run all, and you have to run the single pushover case, and you have to run the single pushover case and click on run now. So these are the steps which we have given before. Okay, our pushover analysis has been completed. As this is a smaller structure, it has been completed. If you see over here, you will be getting the static pushover curve, which is this one. The green line which you see over here is the static pushover curve, which is plotted between the displacement of your structure to the base reaction at the base to the displacement. And you will be also having different types of curves, like according to the ATC 40, etc 40 pushover curve. This is the spectral acceleration and versus the spectral displacement curve, and displacement modification, equivalent linearization. Like this, you will be having different concept. If you, there will be different concepts like a performance point and target point. All those things will be available over here. Target displacement, all these things will be available over here. You can note down the different values, or else you can plot this. You can export this to the Excel file. If you want to export this pushover curve to the Excel file, like click on the display tables. One minute, just I'm just sharing all my screen right now. Share. Okay, can you see the Excel file, like this file? Can you see this, guys? Can you see this? Can you see this table? Okay. This one are the different values of displacements and the base forces. You will be getting the yield value, the ultimate value, and the maximum values from this. I'll be explaining this. You can copy this values, like you can Control C and Control V. Like you can copy and paste them in the Excel, and you can plot the same graph which is available over here. In this, I will be explaining few things. Now, in this up to here, somewhere over here, there will be an yield point, which is your B point, as I have explained before. This up to here, there will be an yield point, and from here to here, like from here to somewhere over here, at this point, there will be your maximum point, maximum base shear, base reaction point, and then you will be moving forward to the ultimate point, and then it will be suddenly dropping. As we have restricted to 24 or 25 mm, it is restricted over here. If you give more values in the conjugate displacement, it will be moving forward also, and it will be dropping like this. This one somewhere over here at this point will be your yield point. This one at somewhere over here, you will be having the maximum point, and here it is your ultimate point, and then you will be having the collapse point. Depending, using this pushover curve, you can estimate the maximum stiffness of the building, or maximum load it can sustain using this pushover curve. Like the maximum load is nothing but your base reaction, and this is the maximum displacement your structure can take without any deformation or reaching the collapse stage. If you divide this base reaction by the displacement, you will be getting the stiffness of the building. If you divide the base reaction with the displacement, you will be getting the stiffness of the building. So this is how you will be taking the outputs from the pushover curve. In the file, you can click on display tables. Your tables will be displayed. It will take a little bit of time to display the table. And after that, if you click on this file, and if you, there is an option called, see over here, there are few points like A to B, the number of hinges formed from A to B, from B to IO. IO is nothing but immediate occupancy. LS is the life safety. CP is the collapse prevention. Whenever you study this at ERDB, like quick resistant building design, earthquake resistant building design, you will be coming across the concepts of immediate occupancy, life safety, collapse prevention, number of hinges formed in that region, it will display, and you will be getting the displacement and the base force value. You have to click on the file and export all tables to Excel. You will be getting these tables in the form of an Excel file. Okay, this is all about the pushover curve. Now let us see the other outputs from the pushover analysis. In this pushover analysis, you will be also getting the hinge formation. How many of you guys know this capacity based concept, capacity based design concept, capacity based design concept? Do anyone of you guys have ever heard regarding this thing, capacity based design? No. Okay, so what exactly is this capacity based concept is strong column weak beam concept. Have you ever heard of this concept? Strong column weak beam, strong column, this concept. Have you guys ever heard of this concept, weak beam and strong column? Yes. Okay, so what exactly is this concept? Can anyone explain? Weak beam and strong column, weak beam, strong column. Okay, let me explain this. So what exactly is this weak beam and strong column concept is, whenever a structure is reaching its failure stage, the first element which is has to be failed in the structure is to be a beam. I repeat once again, whenever a structure is reaching its failure stage or its collapse stage, the first concept which has to be failed is a beam, or the first element which the structure should be yielded is in the beam. If this happens, like whenever there is a building and there are beams and columns in the building, when one beam fail, the effect will be to a certain local area, like around that beam only the effect will be. Are you guys understanding what I'm telling? Like the effect will be at only the area where the beam is failed. But if the column is failed, the complete floors which are above the column will be collapsed. I repeat once again, if the beam is failed, the failure will be localized to that floor itself. But if a column fails, all the floors above the column will be failed, right? So this is the concept of capacity based design. Using this pushover analysis, you can make the structure to fail the beams first, and then the failure will be distributed to the columns. Let's see how they are going to display. Now I have selected the pushover X case and click on apply. Click OK. If you see over here, these are the hinge formations. These are the hinge formations. These are the hinge formations. If you click on the next, you will be seeing different types of hinge formations. Okay, if you see over here, the color of the hinges will be changing from this pink color to it will be changing to the blue color or the brinjal color over here. See over here. There is a hinge formed in the beam first. So if the hinge is formed in the beam, then it is the column is not failing and the beam is failing, reaching its yield point first. So this is the concept of capacity based design. The beam should fail first, and then later the damage is distributed to the adjacent columns. If I click on the right again, click on the right again, this hinges are getting distributed. Now at the bottom column, hinges are forming, the bottom columns are failing, reaching the yield point. If I move further, all the colors of the hinges are changing. Now if you see, it is reaching the D point. The D point is nothing but your maximum point. When it reaches E, the structure will be collapsing. When it reaches whenever you see a red hinge, the structure is collapsed. It is just before the collapse is the orange and the yellow hinges will appear, and after that, when you reach the E point, the structure is collapsed. It means the structure has been collapsed. Now if you see, all these hinges are getting distributed along the structure. So our structure, the last point, let me see the last point of the structure. Display, show deformed shapes, and this pushover. So 98 is the last step. This is the last step. You can also see how the structure is reacting in this 98 step. Click on the start animation, and this is the reaction of your structure. Okay, now I'm just ending this. So this is how you will be doing the pushover analysis using the auto hinges. Now let us go to, are you guys clear with the using of auto hinges? Are you guys clear with the using of auto hinges and the pushover analysis? Hello? Hello? Okay, fine. So the next concept which we are going to learn is using the user-defined hinges. Using the user-defined hinges. Now I'm just opening a new file for creating the user-defined hinges. New model. In this, using the auto user defined, the only thing which changes is the sections and the hinges. Remember two things, the sections and the hinges. For this, you have to go for the others. Whenever you are creating the section, you have to go for the other, and then you will be having an option called section designer. You will be having an option called section designer. Click on the section designer. Now I'm creating a column first, C1, and the base material is M30. This one is a concrete column, and the reinforcement is to be checked. Now I'm giving the properties of the reinforcement also, like the rebar sizes, the placement of the rebar, like the clear cover of the rebar. I'll be giving them. I'll be showing you how to give them. For if you give that type of sections, you have to go for reinforcements to be checked, and then click on section designer, and you will be displayed with this kind of table, this kind of pop-up box, which is called section designer. In this section designer, you have to click on this option, draw solid shape. In this, select the rectangle over here, draw solid shape, rectangle, and place it at the center of your graph, like the origin of your XY axis. Click over here, and a new section will be created over here. Just right click over the section, and you will be displayed with the properties of that section. Now what you have to change is, you have to change the height of the height and width 0.230, 0.430. Okay, and then click OK. Okay, now I just want to interchange this 0.43 and 0.23. Click OK. Okay, now again, there is a section created with M30 grade of concrete, but there is no reinforcement or there is no longitudinal reinforcement or lateral reinforcement in this section. In order to create the longitudinal and lateral reinforcement, just right click on the structure, and in this you will be having the concrete model. Change this to from unconfined concrete to confined concrete, from unconfined concrete to confined concrete, and you will be displayed with a small table a small box. In this, you have to change all the values. Now let us change the size of the main bars. Like I want the main bars to be 20D and the number of bars to be like 10 bars or 8 bars. I'll be giving the 8 bars, and then the confinement bars 415, 415, and the size of the confinement bars I'm giving 10D, or else I'll be giving, okay, 10D is okay. And then the spacing between the bars, 0.15. This is the spacing is nothing but the spacing between two ties. Like whenever you see in the elevation view, the spacing between the two ties is displayed over here. Okay, these are the few things which you have to change. The one is number of bars, the bar size, the confinement material, like the tie bars shape, tie bars material, and the bar size of your tie bars. Click OK. And then in this, you will be having another option called reinforcing. When there is no reinforcement, it is a complete concrete section. If you turn on this reinforcement, it will be asking you for the reinforcement material. FE 500, you have to select the base material. This is for the longitudinal bars, FE 500, and click OK. Okay, now you'll be getting the section which is filled with concrete and having a tie bars, and then you will be having the 8 longitudinal bars. In order to change the diameters of this longitudinal bars, you just have to select it and you have to right click it. You have to select it and you have to right click it. And this changes to 20D, and click on apply on all corners and click OK. Now all the corner bars are changed to 20D, 20 diameter, 20 mm in diameter. And now the edge bars, I am changing them to some 16 or 18D, 16D, and apply to all edges. Okay. Now, as you see over here, there is a lot of clear cover. As you see over here, there is a lot of clear cover in between this main bars and the outermost of the column. In order to change that, you have to select the bars and right click it, and there is an option called bar cover. In this, you can give generally 0.025 or any of the clear cover which you wanted to give, and apply to all edges. Click OK. Now the clear cover has been changed. Now again, in order to change, now if you see over here, there is a new bar added on the top and bottom. As we increase the width, the spacing will be changed and the new bar will be added. If you want to delete this bar, just select this and right click and change the bar spacing from 0.125 to 0.25 and click apply to all edges. Okay, now even these bars are deleted. Now you have to adjust it 0.20, apply to all edges. Okay, 0.15, apply to all edges. Okay. Okay, now by this method, like by changing the distance, by changing the bar spacing, you can add n number of reinforcement or the longitudinal reinforcement over here. Now click OK. Okay, you have created the section. Okay, you guys are following me, right? What I have done, I went into a define section, and in the define section I have went into the section designer. In the section designer, I have used this option called draw solid shape, and then I have edited this section. Now after creating this section, the thing which you have to remember is click on this option called moment curvature curve. Click on this option called moment curvature curve. It will display the moment curvature of the section which you have created. It will display the moment curvature of the section which you have created. From this, you have to take the values of the yield value, maximum value, the C point, the D point, and the E point. This one is your A point. The yield point will be somewhere over here, and this one will be your maximum value. This one will be your the point where it starts to collapse, D point, and this is the ultimate collapse. In order to take those values, what you have to do is take a paper and write alphabets from A, B, C, D, and E. Right on the right side of the A, B, C, D, A, and E, on the top, write moment, and then on the other column, write curvature. Okay, what I asked you to do is just take a paper and write the values of write the alphabets from A, B, C, D, E. Now at the A, in the moment, write 0, and in the curvature the value of A is also 0. Okay, this one is the A point, the value over here is 0 in the moment, and in the curvature also it is 0. Now for the B point is nothing but your yield point. In the yield point, what you have to do is click on the details. If you click on the details, you will be getting in details of this curvature. It will be displaying the yield value and the curvature value, moment yield moment, and the yield curvature values. You have to note down these two options and these two values at B point. The value of the moment is 115.72, and the curvature value is 9.17 to exponential to the power of minus 0.3, which is nothing but 0.0091. After that, you have to go for the C point. In order to check for the C point, just put your cursor over here, and over here it will display the moment curvature. Put your cursor over here and it will display the moment curvature over here. I'm just clicking over here. The moment value is 185.07. 185.07, and the curvature value is 0.042. The curvature value is 0.042. And next I am going to the D point. This is your D point. The curvature value over here is the moment value over here is 153.71. 153.71, and the curvature value over here is 0.48. 0.48. And then again I am going to the E point. This one will be your E point. The value of moment over here is 26.17, and the value of your curvature is 0.54. Okay, if you have noted down those values, just anyone from the chat box, just put the values in the chat box, like the A value. I'm asking the A value. What is the moment at A and curvature at A? Hello. What is the moment at A and curvature at A? 0, 0. Yes. Okay. What is the moment and curvature at B point? At B point, 115.71. Yes, exactly. At C point, at C point, okay. At D point, at E point, at E point. Okay, right. So I hope everyone have noted down these values. So after this, what you have to do is click done over here, click on done over here, and then click done over here, and then save the section. Save the section, click OK, and your C1 section has been created. Now you have to create the B1 section also. I'm just creating it fastly. And in this section designer, you will be only having the concrete column. For beams and columns, you will be using only the concrete column. And this reinforcement to be checked. The base material to be M25, section designer. Should I explain this once again, guys? Or are you guys following? I'm asking you guys, just put in the chat box. Should I explain it once again, or is it okay to continue? Guys, I need you guys to respond. Where do we get section designer tab? Okay. Once again, get section designer option. Just send it once more. Okay. A few of you are asking me to explain once again. I'll be explaining this once again. Just note down the values of this. What do we say? Beam also. Moment curvature values of this beam also. And again, take a paper. A B C D E. C D E. Moment curvature. At A it is 0, 0. I'll explain it once again after completing this beam section. Now for the yield value, the yield is at B section 80.135 and the curvature is 0.0149. 0.0149, and the next one is at the C value. The C is nothing but your maximum value. The yield is the moment is 0.20 to 120.19 and the curvature is 0.046. And at the D point would be somewhere over here, and the D point would be curvature moment would be 105.07, and the E point, sorry, I haven't noted down the value of 0.92 is the curvature value, and at the end we'll be having the E point. It is moment is 92.45 and the curvature is 1.04. Okay, right. Click on done. Save this section as B1 and click OK. Okay, you have created two sections and click OK. Now I'll be explaining you guys. Listen carefully now. Click on the define section properties, frame sections, add new property. Initially it will be like this, not like initially it will be like this. In this you have to go to the other. you have to go to the other, and you will be getting the section designer. Click on the section designer, give it a name, specify the base material, concrete column, reinforcement to be checked, and the section designer, you have to use this to create a shape. This option rectangle, you have to use this to create a shape. And then after giving all the values, if this value is highlighted, this option is highlighted, and you have to click on moment curvature curve, and then you have to note down all the values. Okay, now let's continue with the modeling. Now I have created sections. Click on, now we have to model this building. So for that, quick draw frame tables. I'm creating the beams first. Hmm. Okay, we have completed our modeling. Now just I'll put few loads. Loading part is also been completed. Now you have to create user defined hinges from the values which you have noted from the section designer. You have to create user defined hinges. For that, you have to click on define section properties. This is a very important part in this user defined hinges. So you have to click on define section properties, hinge properties, add a new property, and you have to create a concrete hinge. Okay, and you have to specify the hinge name. First I'm giving for the column hinge, and then the load which I want to create the hinge for is for axial load and the moments. So you have to select P, M2 and M3. And in this, you have to select the moment curvature option, and you have to enter the data which you have noted down before in this option. Modify show moment curvature data. In this, you have to enter the data. If you see over here, moment by yield value, at A it is 0. At B, if you divide the yield moment by yield moment, you will be getting 1. At C, you have to divide the C point moment at C point with the yield point, which would be 185 divided by 115. 185 divided by 115, which would be 1.60. You have to change this to 1.60. 1.60. You guys are understanding, right? Moment by yield moment. Yield moment by yield moment. This one is at the C point. Whatever the moment you are getting, you have to divide it with the yield moment. So if I divide 185 by 115, I am getting 1.60. Similarly, for the D point, if I am dividing 153 divided by 115, I'm getting 1.33. 1.33. And for the E point, 115 divided by 126, I'm getting 1.09. 1.09. And here you can directly enter the values of the curvature. The values of the curvature at C point is 0.042. At B point, sorry, at B point is 0.0091. And again at the C point, it is 0.042. And at the D point, it is 0.48. And at the E point, 0.54. Okay, I repeat this process once again, guys. After entering into this dialog box, you have to enter the values of moments and the curvatures. You have to calculate it by dividing with the yield moment. At A, it will be as usual 0. This point will be 0. At B point, you have to divide the yield moment with the yield moment. It will be 1. And at the C point, which is nothing but your moment at C divided by the yield moment, which will be 185 divided by 115. You will be getting this value. And similarly, at the D point, you have to divide 153 divided by 115. You will be getting this 1.33. And similarly, at the E point, you have to directly enter the values of the curvature over here. Why? Because the SF value is 1. User defined SF value is 1. So you can enter the values directly over here and then click OK. And again, click OK. And again, click OK. You have created one hinge. And again, you have to click on add new property and click on the concrete and click OK. And over here, I'm creating a new hinge for the beam. And in this, again, I'm selecting the P, M2, M3, and you can select the M3 also just for the moment. Why? Because in the beams, the axial forces are not developed. So you can select the major moments, or else you can go for the PM to M3. Now I'm going for the PM to M3, the moment curvature. In this, again, I am entering the data. The value at C would be, can you guys quickly give me the value at C? 80 divided by 120, sorry, 120 divided by 80. Can you guys quickly give me in the chat box? One 120 divided by 80. Okay, 1.5. 1.5. What will be the value at D? value at D, value at D is 1.31, 1 minute. So it will be 105 divided by 80. If 105 divided by 80, the value is 1.31, right? 105 divided by 80, it will be 1.31. Okay, so it will be 1.31, and the value at E, 1.15. Now I'm quickly entering the values of the curvatures also. 0.0149, 0.046, 0.48, and 0.54. And then check your curve, click OK, and again click OK, and create your second hinge, and then click OK. Two hinges have been created. You have to assign these hinges to the frame, to the appropriate frames. The C1 should be assigned to the columns, and the B1 should be assigned to the beam. Click OK and select. In the select, go to the first. I'll be assigning the, sorry, you have to create a load pattern also. The load cases, add new load case, gravity, static nonlinear, load pattern did add on the live 0.25, add, and click OK. A gravity load case has been created. Click OK. Now select the beams. I'm selecting the beams first. Select assign frame hinges, B1 hinge at 1 distance and at 0 distance. This one is, the remaining process is similar to the first pushover case which you have done. Apply. Okay. And now select the columns. Assign frame hinges C1 at 0, add hinge, and at 1, add hinge, and click apply. Okay. Now you have assigned the hinges to the columns and then to the beams, right? The next thing which you have to do is click on define, create a load case, add new load case. This one will be push in X direction, difference from the end of gravity load case. This will be static nonlinear load case, and the load pattern will be acceleration. Now let me, okay, UX, and then this one will be -1. This one will be your displacement control, and click OK over here, and then in this click on multiple states and 0, and then again 0, click OK, and then make the remaining to the default and click OK. Okay, 1 minute. Okay, in this I haven't added, click OK. We have created a pushover case. We have created a pushover case. Click OK, and then I guess what you guys know what to do next. Click on analyze, set load cases to run. Do not run all. Run the first 4 load cases and click on run now. So this one is the convergency which in the background it will take place. You have to look out for the total number of saved steps. Like the count should be increasing. If it is increased, the convergency will occur, or else the pushover won't take place. This one is a gravity case which is going on. This one is a gravity case. Okay, fine. Now you have to go to the analyze, set load cases to run. You have to click do not run. It is okay if it is not finished over here, and you have to click this as do not run, and run now. Two steps have been saved. Should increase. If the null steps reaches to 50, the analysis will end. So within the null steps, you have to get more steps. As we are not reaching the steps, you should change the nonlinear parameters. Okay, you can see only up to here there is no line formed, just a horizontal line formed in the pushover curve. So you need to change the nonlinear properties. In order to change the nonlinear properties, just unlock the model. Now I'm just running all the cases at once.
Yeah. Arun, so I think you can inform students what things left and what we are going to do it tomorrow.
Okay. Okay, sir.
Mm.
So, guys, this is the method. This is the pushover method for with using user-defined hinges and auto hinges. Actually, it is analyzing in the background. It will continue like this. For the next section, in the next section, actually, we are left with the time history. I was about to take the time history today, but as for the time restraint, I am just postponing this time history method to the next class. In the next class, in the next FTB section, we will be learning regarding the time history section, like using the unscaled ground motions and the scaled ground motions. Along with that, we will be learning how to import an AutoCAD file into our SAP file, SAP program, and how to analyze it and how to create a model based on an AutoCAD file. Okay.
Right, yeah, that's it, Arun. And tomorrow we are going to do one example model also, right?
Yes,
Or we can
that's what, sir. That's the AutoCAD model, sir. I'll be importing an existing file which
exactly.
I have worked before, a live
Okay.
project.
And one more thing, we can show the projects which we have done on the real-time projects, like shear walls and all. We can
Yes,
show
sir.
them all the time there.
Yes, sir.
And one more thing, through SAP, how can they extract model images, graph images into PDF? So that also we'll try to show them tomorrow, because whenever they are doing MTech projects, so they need to submit in a form of a document, right? So
Yes,
that
sir.
photos, I mean the modeling images, graph images, how can they make it into PDF or some JPG formats also? We will show it tomorrow.
Yes, sir. Definitely, sir.
Okay. Right, yeah. Okay, guys, then yeah, that's all for today. So I think we delayed for 15 minutes, so that's why we continued the class till 1:20. And tomorrow, as Arun told, we are going to start with the pushover analysis, right? Pushover, right?
No. Tomorrow we'll be starting with the time history. Pushover is
Sorry,
completely.
time history analysis. Yeah, so might be 2 hours is not sufficient for closing tomorrow's session. What we do is we will try to extend more 1 hour, and we will try to close the tomorrow session, and we will have a vote of thanks tomorrow also. Okay, so and we will have a final feedback tomorrow. So that's how we are going to close it, the end session. And please bear time for tomorrow. I mean, make your time tomorrow for at least for 3 hours. Okay, that will be good enough. Okay.
Yes. Yes, sir.
Yeah.
And few more things I want to deliver, sir.
Please,
Like,
please.
guys, whenever you are thinking that I'm going fast, or the trainer Tejaswini is going fast, just let us know in the chat box that we are going fast, and we will be slowing down for you. And you guys don't worry, like if you have missed anything, any part you haven't understand anything in this session, it will be the video output will be given to you, and in that video output you can check them once again. Okay. Yes, 3 hours continuous section tomorrow. So this is what I want to convey, sir. So that's it for today's session, and we'll be continuing the time history in the tomorrow's section. Hello.
Yeah. Okay, Arun. So we will wind up the session. Okay. Yeah. So guys, thank you so much. And tomorrow, please, I request everyone, so please be before 10 minutes. Okay. So by that we'll start session exactly by 11 o'clock. Okay. Right. Thank you. Thank you so much.
Thank you, guys. Thank you very much.
On some committees in the department, we have to go through inspection. Mark will start from 21.